I guess we'll start. We're already a few minutes late. We are still missing one speaker, but I have good hope that he will show up in time. And otherwise, we have a volunteer that was willing to talk anywhere between 5 minutes and 3 hours. So we should be good to go. Welcome everybody. My name, for those that don't know, is Klaas Wieringa. I am a member of the program committee. But also before that, I think it was 6 years ago, Thomas Schmid over there, and I said it's really a shame that the NREN community is not very present in the IETF anymore. How can that be? Why is that? And we thought that we could at least contribute something by bringing people that are active in the IETF to talk about what we have called hot topics of the IETF, things that we think that the NREN community should know about, or where we know that there is interest in the topic. And I think over the years we have managed to get some really good presenters, and I'm happy to say that I think the same goes this year. I think we have a few very interesting presentations coming up. And the first one of that will be by someone you may know because he's wearing many hats in this community, Leif Johansson. He has been for 3 years in the program committee now. He does this hardware crypto module. He's chair of 3 IETF working groups, and is basically the oil between many federation activities. But today he's going to talk to us about SCIM, protocol that the abbreviation that used to stand for Simple Cloud Identity Management, but it turned out not to be simple and not to be cloud. So it now means something else, and Leif will tell you all about that and why that is relevant for your community. Leif, the floor is yours.
Thank you, Klaus. So we're doing this, not the... Is there a flipper? Yeah. That's it, right? Hey, hello everyone. So at the IETF session is that's clearly the place to wear a suit. I was born in 1968, which makes me part of the ironic generation, and you'll figure out the rest from there. I'm going to talk a little bit about SCIM. The background of the name is actually more interesting than the protocol. In many ways, it sort of started out as one of these webby ad hoc collaborations on the internet between vendors, and of course they used both the forbidden S word, simple, and the forbidden C word, cloud. When they decided to bring it all into the IETF leadership told them that what the hell, we've had too many simple things that turned out not be simple. They also forbade them to use the word lightweight anywhere in there, and cloud clearly has to go. But in good IETF tradition, we managed to figure out a way to backronym SCIM into Simple Cloud Identity Management. So we sort of lost the battle on simple but won the battle on System for Cross-Domain Identity Management, I should say. So identity is not a word you actually see in a lot of IETF protocols, and it's sort of ironic that we happen to be this one, which is sort of not really identity. And I'll get back to what it really is and what it can be used for. A lot of people clearly still think of this as simple cloud identity management, and that's a pretty good description for what it's trying to do. So I'm actually going to talk a little bit about what it is from a techie perspective, what it looks like. I'll show you a couple of examples. But I'll start by doing sort of the non-expectation here, right? It's not LDAP. A lot of people who here knows about LDAP? Right? Everybody knows about LDAP. The thing is, if you ask that question in an audience about 10 years ago, it didn't look like that. LDAP is one of those technologies that has moved away from being a hot topic in standardization circles and in web circles, but it's one of those things that everybody uses, right? It's absolutely pervasive technology. It's not pervasive monitoring technology, but it's pervasive technology. It exists everywhere. Where there is identity management, there's going to be an LDAP interface somewhere. Now, of course, well, not of course, but it turns out that as we move from a vendor-centric, software-centric world to a deployment-centric world, where instead of buying software we deploy in our own data centers, we buy access to services, the world tends to run over HTTP, for good or bad. And it has occurred to people that, hey, let's just do an LDAP over HTTP. SCIM is not that. And I doubt it if anybody ever was going to be successful in actually doing an LDAP over HTTP. So what does SCIM actually look like? Well, it's got all of the cool hipster stuff, right? First of all, it's HTTP. This is an example of a SCIM request. Do I have a laser pointer? Yeah. So it's a little bit of there's a post here. It's a typical HTTP request. It's a post request. It's got some HTTP headers. I'll get back to this one. And the content is JSON. Now, for those of you who are old enough, who is old enough here to remember ASN1? Okay. Who is old enough to remember XML? There was this thing called XML, right? Yeah. So my theory of the world is that everything is about rebelling against your father's data description language, and you're sort of moving as the kids grow younger, they keep rebelling. Of course, they rebel at an increasing Netscape sort of inflated rate. So at this time, we're not even finished deploying JSON everywhere before people are now starting to talk about the next generation thing. Something called CBOR is being floated, which is essentially a binary again, so we're back to ASN1, right? But still, this is not really, in my next slide, I claim this is hipster technology. It sort of isn't anymore. This is your granddad's technology now, at an accelerated rate. So looking ahead, well, there's HTTP stuff. The internet runs on HTTP. Everybody knows that, if you didn't. This stuff over here is kind of interesting. There is an implicit implication in most of the specifications around SCIM that the authentication layer will be OAuth, right? So if you didn't know OAuth already, didn't implement that for your stuff, now's the time, probably. And of course, everything is formatted as JSON. Now, one thing worth noting here is that they actually thought about Schema Extensibility, which is a good sign. A little bit later, I'm going to say a few words about sort of the dynamics of SCIM and the IETF and how it sort of actually matters for both the IETF and some of these more non-structured communities. So, what do you use it for? Typically, it's used for user and group provisioning and deprovisioning. That's an important thing to remember. There is extensibility in SCIM. It isn't just tied to users, and it isn't just tied to groups. You can do other things. But certainly, if you were to pick up a SCIM server today, or a SCIM connector, or a SCIM interface, there's going to be hidden and built-in assumptions that it's mainly about users and groups, right? So the origin of the SCIM protocol suite is an explanation for that, because it was created by companies like SharePoint, who wanted a unified interface for provisioning users into their services. Now, why is that interesting? I mean, if you're SharePoint, you own like a significant portion of the identity management space in the world, right? If you didn't know that, who didn't know that SharePoint is the de facto identity management in the world? For end users, yes. But for corporate applications, no. For corporate applications, a lot of identity management is actually sourced inside Salesforce. Right? So if you're Salesforce and you want a standardized interface, right? If you're somebody who relies on having an identity management ecology together with Salesforce and SharePoint and some of these other sort of typical brands in enterprise IT, then you really want a standardized way for provisioning and deprovisioning users, and that's the reason for SCIM. So why isn't this just federation? Now, some of you are thinking probably at this point, but you know, when we build federated identity, connect up services to federation, we typically do provisioning on demand, right? You create a user based on the rights that the IDP asserts for that user, right? So why would you want SCIM? Well, in some parts of the world, people haven't gotten this yet. They still think that things like federated identity is just about authentication and not about claims and identity. Well, okay. But for us, for our community who have sort of gotten that bit about just-in-time provisioning, we still need to figure out how to do deprovisioning of identities, and we haven't done that. We haven't even gotten a good handle on the problem yet. John is snickering. Yeah. I suppose that's why you turned off responsibility for the Uninet box thing just in time for people to start to have to sort of deprovision accounts. Yeah. Deprovisioning, I think, is going to be the reason we engage and need to implement this stuff. So who is involved? How much time do I have? Yeah, okay. So who are the players? Well, Klaus pointed out that I'm missing his company here. Yeah. So imagine at the head of that, it says Cisco and WebEx. Yeah. There are open source people here. There is something called co-manage. Heather will be happy to hear me say that. That probably implement this stuff. If you look here, you'll see, you know, Oracle, well, large database providers, not so surprising. Unbound ID, smaller company that tries to do identity management. Microsoft, Salesforce. Quite a lot of the SaaS providers are watching this and waiting for it to stabilize. There's been in the effort in the IETF has been focused on sort of taking the standard to some sort of version 2.0, and in that time frame we've seen notably Microsoft take a really big interest here, probably because the next or current, I can't remember, version of SharePoint essentially tries to be a corporate Facebook. And there's been push from some of these vendors to actually duplicate the Facebook Graph API into SCIM. Kim Cameron did a blog about that a few months back, or maybe a year back, saying that, you know, Graph APIs need to be standardized. Nothing much has happened about that lately, but you know, I wouldn't be surprised if it pops up again. Does anybody know what the Graph API is? Hands up who understands the term Graph API. Okay, only two. Then I'll explain it. So, inherent in the LDAP model is the notion that information about users and groups, identity management, is a hierarchical structure, right? There are countries, there are organizations, there are organizational units below organizations, etc., etc. Increasingly, that's not how organizations actually look like, right? More and more, they're unstructured collaborations between federated groups or whatnot, right? I mean, it's a lot more unstructured. And if you look at the social applications like Facebook and Twitter, their way of representing friend relationship actually models much more closely how we actually work and how we tend to organize ourselves. If you just look at the NREN community and try to figure out who are my core collaborators, they're probably not going to find, you're not going to find them in a single OU in an Active Directory somewhere. right? So the Graph API is Facebook's de facto standard for representing and accessing information about human-to-human relationships, right? So it's not that strange to think about having a standardized way, taking LDAP, the LDAP notion, one step further away from the hierarchical organizational models to a more unstructured model, and have that be something that a vendor like Microsoft actually wants in their stuff. So I'm going to talk a little bit about how it came to be that SCIM wound up in the IETF, and what it sort of says about the IETF process, and what it says about some of the groups who are doing things that look a lot like standardization, but don't turn up in the IETF. So as a long-time IETF contributor, I'm one of the people who like the balance between structure and unstructured process that exists in the IETF. I've never myself been participant in the ITU. Some of you may have done that, right? May have done that, and you'll know that there is a big difference how things work. You know, there is a difference in making decisions, in preparing documents, in establishing consensus, right? If you were to ask, if you were to go to, some of the startups in Silicon Valley where all the hipsters live and ask them, what do you think about the IETF? Very likely you'll get sort of the same type of answers that you'll get that you used to get from the people who formed the IETF about the ITU about 20 years ago, right? Oh, that's just where TCP, I've heard of TCP, right? It's where the lower layer stuff happens, right? And some of that is certainly not deserved. But there are definitely a lot of cultural differences between how the precursors to the SCIM effort in the IETF came about and was happening and was producing stuff before they decided to take it to the IETF. Now, it's worth asking, why did they decide to sort of leave their ad hoc collaboration and bring it into an IETF setting? Well, I think the most important answer here is IPR. In a collaboration between organizations and between companies, getting intellectual property rights right is really difficult. And the IETF has a really good way of handling intellectual property. It's open and it's very transparent, right? Getting to that point is expensive. And if you want to duplicate it, there are many traps you can fall into. Now, I suspect that's probably the reason why groups like SCIM, or before them the OAuth community, which was even more loosely collected and anarchistic and strange sort of collaboration between rock stars, decided to actually bring their stuff into the IETF. Now, there have been quite a few, there's some interface friction between how the IETF typically works and how some of these communities typically work. For instance, there are technical differences. A lot of these guys rely on weekly conf calls. That's traditionally not been the way the IETF works, right? It's mailing lists, right? There are good reasons for saying let's stick on mailing lists, because there's a public record of who said what and why, right? Going back to Stephen's keynote this morning, right? If you want to figure out who has a nefarious motive, the best thing is to look at their actions, right? And how do you judge their actions if you don't have a record of their action, right? Those are legitimate concerns. In SCIM, it used to be very informal. We do a conf call every week. We keep a set of issues open on GitHub, and we close them as we decide that they need to be closed and open, right? Very little sort of tracking. Bringing this into the IETF, actually we had to make sort of concessions and a bit of compromise on both sides, right? the community needed to keep a little bit of how they used to work. And the IETF had to impose a little bit more order. So we actually wound up combining two. This is how I wound up chairing this, because I guess I was seen as the process geek, which is kind of strange. Yeah. Yeah, I mean, there are ironies on many levels here. It just doesn't end. So all of the social things aside, and I actually find those things really interesting because it has implications for our community. As Klaus said, you know, why aren't we contributing more to standardization? And standardization feels like such a boring topic, right? Why would you care about standardization? Well, you care about requirements, though, right? You care about requirements. You care about the next time you go to buy a product, or you know, buy a service. What you care about in consuming that service has been taken into account. How does that happen in the commercial world? Well, vendors influence each other by, no surprise, turning up at standardization groups, right? I've seen situations in the IETF where people large vendors were packing the room as it is, right? Because they were really, really interested in one particular idea or really interested in that idea not happening. Right? We don't do that because I don't know if we believe that somehow our requirements will be communicated to the world by telepathy or something. Doesn't happen, right? It turns out it isn't that difficult to influence the SDOs. Stefan Winter, who's sitting right there and wishing I didn't point to him right now, you started out basically as a newbie in the IETF, what, 4 or 5 years ago? And it took you like 2 or 3 years to get one of the major change, a fundamental change, right, into the way people treat radius. It used to be that before Stefan and the Eduroam community got engaged, people in the radius community thought it was sort of UDP always, right? And that change was one person making a concerted effort. You know, you can just imagine what we could do if we actually turned up in force. Anyway, so back to SCIM. Why should you care about SCIM? Well, first of all, if you buy SaaS services, right? If you're buying a portfolio of SaaS services, let's say like somebody with a Net Plus ambition, right? You're buying more than one Net Plus service, and you want to get your identities provisioned in all of them. Are you going to build a connector or an integration for all of them? Does that sound like a good idea? No. You want one integration point. And first of all, first and foremost, you want one way of integrating everything. Are you implementing IDM? If you're a research community with your own VO system, right, where you need to provision groups, you're running something, you're developing or running something like co-manage, right, or VOMs or anything like that, and you ever wanted your identity management system to talk to anything else, right, like a SaaS service, right? Today it's LDAP, tomorrow probably it's SCIM. Are you doing federated groups? Andreas up there, I'm tempted to point to you with my laser pointer, but I'm going to do it. Andreas, who's sitting right up there, right, has spent quite a lot of effort thinking about how does federated groups work, right? Now, I know that Andreas is actually looking at SCIM. Or if you care about deprovisioning, if you care whether your users stop using services, i.e. if you get to stop paying for services when your users stop using them, right? Not entirely unimportant. So I guess that's a call for action. SCIM, as an effort, is sort of winding down, right? We're at the point where we have a, pretty soon we have a stable API, a stable core schema, and if you wanted to have any chance of making any kind of impact on SCIM, go read those documents, the core documents, go search for draft IETF SCIM on Google, you'll find them, read the latest one, turn up on the mailing list and comment if it doesn't look reasonable to you, right? And with that, I'll take questions.
Yes, we have room for 1 or 2 questions, so please raise your hand if you have any.
Everybody looking at the origami Nazgul. They're on the web. Interop, good question. So, gentleman over there asked about interop testing. SCIM, by the way, and Chris has been one of the people active in the SCIM community. Thanks for that. There has been interop testing, mostly for the previous version. I'm expecting that there will be a flurry of interop activity fairly soon as we start to finalize SCIM 2.0. If you are doing SCIM implementations, this is really a time to get involved, because the SCIM community has tended to sort of go for, let's test for a couple of months, make sure everybody who turns up are interoperating, but then they will close that effort down, and you're basically out of luck if you're not there.
After the plenary session, I can only ask one question. So, what type of encryption do you use to secure the transport? So,
and I'm sure we'll get Stephen Farrell is going to do a security review of this, and he's going to. Didn't the microphone work? All right, let's
work now. Yeah.
Yeah.
After the plenary, I can, of course, only ask one question. What's the security, and what type of encryption do you use?
So. The mandated or the recommended way of doing this is to run it over TLS, right? Which is sort of a standard answer for these kind of things. Is it a good answer? Not entirely sure. I think there are legitimate concerns over how we use bearer tokens as security elements today. I mean, if you go back to my, doesn't work anymore. If you go back to this thing, right, what that is essentially a glorified cookie. It's been established somehow out of band of this transaction. There is very little to tie this thing to the TLS context. I don't know when I'm looking at that whether that's been given to me over a TLS. Channel bindings is a concept that you should Google for and find out. There is this is sort of related to something called channel ID. It's a Google proposal to essentially mix in cryptographic content from the bearer token in the TLS. And that theoretically should make it a lot harder to steal these things. Whether channel ID or some version of it, because it's sort of not the first proposal to come along, whether that will sort of get adopted or not. It's also related to something called the FIDO Alliance, which you should definitely watch, but I would say not get involved with, because they're a bunch of closed, walled-off garden. It's a private boys club, and you should tell them to stop being a boys club before getting involved. But what they're doing is really important.
Thank you, Leif. I have to stop you. Can I get an applause for Leif? So, Colin, can you come up and start your slides while I'll introduce you? So the next topic is actually, it's kind of interesting. Last Monday there was the TERENA Technical Advisory Council, and that's where, for those that don't know, the NREN community representatives get together and talk about what they think will hit them in the coming years and how they should approach that. And one of the things that was brought up and seen as important in the near future was the concept of WebRTC. And we would not be your program committee if we had not already anticipated that and brought in one of the authorities on WebRTC. WebRTC is at the moment kind of controversial because there are basically two camps fighting about video codecs, etc. And we thought it would be good to get the perspective of one of the people heavily involved in this work, and essentially I would like you to go away with an answer to the question: is this something to ignore for the next couple of years until the big boys have fought it out? Or is this something that, as an NRAN community, we need to get involved in as they move forward? Well, for that, we have Colin Perkins. We are now actually moving on to the part where we have more difficulty understanding the speakers, because they're all native speakers from Scotland, Ireland, England, USA. So now it will get hard. But Colin is a senior lecturer at the University of Glasgow and has been involved in many of the video activities in many standards bodies, including in the IETF. And he will tell you about WebRTC.
Okay, thank you. Can you hear me like this? Do I need to pick the microphone up? Yeah, good. All right, so thank you for the kind introduction. I'm going to talk about multimedia transport protocols for WebRTC. And to begin with, I want to say a little bit about what is WebRTC. Well, the idea behind WebRTC is to provide a framework for native browser-based real-time video conferencing, video chat applications. The idea is to integrate all the necessary components to build applications such as Google Hangouts, the various click here to talk to your you click here to have a video chat with a sales representative, things like chat roulette, that sort of application. Build all the features you need to do those natively into web browsers, so you don't need a Flash player or any form of other, like the Google Talk plugins. You don't need native code plugins to support this. And to do so with a JavaScript API, and as a result enable innovation in browser-based real-time video conferencing, video chats, telephony type applications. WebRTC is something that's being developed jointly by the IETF and the World Wide Web Consortium. There are working groups in both of those organizations. The protocol is called WebRTC. The W3C working group is also called WebRTC. To cause confusion, the IETF working group is called RTC Web, so you'll hear that name occasionally. But they're all working reasonably closely together to develop this protocol, and there is actually a fair amount of collaboration. There's actually a joint meeting been happening this week between these two groups. Things are progressing. We hope to have the standards finished hopefully later this year, beginning of next year. In terms of the pieces of this standard, what's being developed in the IETF side is a mix of transport protocols, NAT traversal protocols, and signaling protocols. The IETF is profiling some of the existing multimedia transport protocols. It's taking RTP as the base, the secure RTP extensions, and a bunch of the other RTP extensions that have been developed over the last 20 years or so, and is developing a standardized, a consistent set of extensions and profiles for RTP, which will be implemented in the browsers. It's developing a peer-to-peer data channel as using SCTP tunneled over UDP to give a peer-to-peer data between the browsers. It's profiling some of the NAT traversal solutions, stun and turn and ice, and developing a consistent set of NAT traversal protocols, again, to be implemented in the browsers. And it's developing the basics for a signaling infrastructure, which is decoupled from the actual mechanism of doing the signaling. And I'll talk a little bit more about that in a minute. But it's basically building on the ideas from SDP and the offer-answer exchange that was used in SIP, and decoupling them from the actual the SIP protocol to allow us to build more interesting applications. In the W3C side, there is some work in identity provision, which also comes a little bit into the IETF, so you can figure out who you're talking to and whether you're authorized to talk with them. And the W3C is also doing the appropriate browser extensions for media capture, real-time video encoding, real-time audio capture, media playouts, media transport, and the like. And building JavaScript APIs, which can be used to control all of this, so you can download particular applications into the browsers and implement the type of conferencing application you need. To briefly sketch the operation of the protocol. Right? Assume you have a web server somewhere and a couple of WebRTC-enabled browsers. Currently, this would be the latest versions of Chrome or Firefox, and I believe also Opera. Hopefully, this will be the full set of browsers in the future. Initially, the WebRTC application gets downloaded into the browsers. Now, you say downloaded, but this isn't the sort of typical application download you have to do now, where if you want to use Google Hangouts, for example, where you download a native plugin which gets installed in your browser and then configures it to do the video conferencing features. What we mean by a download here is that you visit a web page, and as part of loading that web page, some JavaScript code gets downloaded into your browser. And that uses the WebRTC API and the WebRTC extensions implemented in the browser to configure it to perform this video conferencing application. Yeah. The application then gives you something like a button that says, click here to talk to a customer representative, or click here to chat with your friends, or whatever it is. When you click that button, the JavaScript code in the browser uses the WebRTC extensions, the WebRTC API that the W3C has standardized, uses that to configure the browser to begin a conferencing session. Now, in practice, what that means is it figures out the capabilities of the browser in terms of which media codecs it supports, whether it has a camera, whether it has audio capture, what video resolutions it can support, the details of its network connection, and so on. And it gets a description, a session description which represents the capabilities and state of the browser, which it can then pass up to the web server through the WebRTC signaling channel as the first part of starting the application. Now, when I say WebRTC signaling, it seems like there's a defined protocol. In practice, what you have from the browser is a session description in SDP format, which should be passed to the corresponding peer who you wish to talk to. But the WebRTC protocols don't specify how that is to be done. So in practice, what happens is the JavaScript application uses the usual HTTP mechanisms, whether it's a post request or a WebSockets channel or something along those lines, to pass this to the server. And the back-end infrastructure running in the server locates the person you wish to talk to, and again, using the usual web mechanisms, passes it to the party you're trying to call. Assuming that person wishes to talk with you, it passes that offer into the WebRTC part of the browser, which will do whatever is needed to configure their browser to perform a conferencing session and pass back an answering session description, which again goes through the signaling channel up to the web server and gets passed back down to the originator. At this point, both are ready to begin the conversation, and the actual peer-to-peer data connection begins being set up. WebRTC implements some NAT traversal features in the browsers. These require a rendezvous server out on the public network, which will be typically implemented somewhere closely co-located with the web server that's serving this application. This is used to figure out the NAT bindings, figure out the public addresses of the outside of the NAT bindings for the browsers as a rendezvous point primarily, and hopefully then set up a peer-to-peer path with UDP traffic flowing directly between the two browsers. Once all that's been done, the the media, the data, the audio, video can start flowing, and the actual real-time conversation can happen in a peer-to-peer manner, hopefully without having to go via the web server. There are fallbacks for relaying the media in the cases where the net traversal doesn't work. Now, there's a bunch of components here. There's an application provider, the website that is implementing this conferencing application. The site implements the application in JavaScript. It's just downloaded, same as any other JavaScript code, into the browser when you visit the page, and uses the infrastructure built into the browsers. There's a lot of flexibility in how the application looks, how it gets configured. It gives you windows into which you can render video, and how you arrange those, what the application looks like, what Chrome is around them, is entirely up to the application. So the application provider, the website, is responsible for this JavaScript code to implement the conferencing application. It's responsible for providing the necessary identity management and authentication and authorization infrastructure, which may be something as simple as, are you a Facebook friend with the person you're trying to chat with? And it's also responsible for providing the appropriate NAT traversal infrastructure, at the very least a stun server to do the rendezvous. In terms of signaling, the browsers just give session descriptions, and it's the responsibility of the application to pass those between the browsers, and the session descriptions would give everything needed to set up the sessions. The protocol is defined by the application. There's no standard signaling protocol, so we're not implementing SIP or H323 or any of the many other signaling protocols here. It's entirely custom depending on the application. And if you wish to build SIP in JavaScript, you're welcome to do so. I would suggest there are probably easier ways of doing this for most applications. And then in terms of media transport, in terms of NAT traversal, we have stun with a fallback to turn, and the ICE mechanism, which is a reasonably well standardized mechanism for NAT traversal. That will hopefully set up a peer-to-peer data channel using allowing the browsers to exchange direct UDP traffic. The media transport then uses secure RTP over UDP with a datagram TLS key exchange. And the peer-to-peer data channel is SCTP, again, tunneled over datagram TLS. And again, back to the pervasive monitoring, I am told that if this is configured appropriately and the authentication and PKI and so on is done correctly, this can be secure. I am not one to be able to evaluate those claims. There are a number of benefits to this. I think some of the nice thing this gives us is standard APIs and infrastructure. It gives a reasonably high-level, relatively easy to work with API for building conferencing applications in a very widely deployed platform, because it just runs in web browsers. It gives us a standard set of infrastructure. It gives us a standard set of media transport protocols, a hopefully agreed set of media codecs people are using, and standard pieces of backend infrastructure. Right? All the browsers will use the same way of doing NAT traversal and the same rendezvous infrastructure to manage the NAT traversal. So this simplifies deploying these things because there'll be a standardized package that you can implement. It gives flexibility for the applications. You can download whatever you like into the browsers in the JavaScript code. And what the application looks like, what features it uses, whether it's audio or video, point-to-point, multi-party, is entirely up to the application developer using this API. It gives a modern set of media transport protocols. It uses RTP with the appropriate extensions for robust media transport, security, and the like. And uses a decent set of modern codecs. It's got the Opus audio codec, which is actually a pretty nice, open, robust, high-quality wideband audio codec. And, well, there are still arguments over exactly which video codec is being implemented, which will hopefully play themselves out. But the main proposals are being H.264 and VP8, and that they're all good quality codecs. And well, I expect the interoperability issues will be resolved eventually. IPR as always. There are also some challenges. I think one of the challenges which the working groups have wrestled with is API complexity. And to what extent you provide a very high-level API that lets you do very basic applications simply, and to what extent you expose all the low-level details to give control and allow you to implement the most flexible thing possible. And there have been proposals to do very low-level APIs, exposing every single detail of the process, and proposals to do relatively high-level APIs. What seems to have won out is a relatively high-level API that makes it simple to do simple applications, but because it exposes a lot of the control knobs in the form of an SDP session description, it makes it not particularly straightforward to do sophisticated things, although it does seem to be possible. So there's been some issues and some complexity there. NAT traversal performance, I think, is going to be a challenge. The stun, turn, ICE protocol suite, which is implemented, as far as I can tell, is going to work very well for that. But I don't think we've seen deployment on this scale yet, and how well it will actually work in practice is still a slightly open question. I think there are some issues with making sure the security achieves its potential and really works in practice and really gives end-to-end security, which it's not necessarily clear that we have the back-end infrastructure, the identity management to achieve that. And the thing I'm going to talk more about is some issues with actually getting the media transport and the congestion control to work reliably. So what's the issue with congestion control, with media transport for WebRTC? Well, what we're trying to do here is build safely deployable, high-quality, high-performance video content. Now, in some ways, this should be straightforward. The media transport protocols use RTP, which is getting on for a 20-year-old standard now, and is pretty well developed, pretty mature, and works very well for what it does. But we're deploying it at a very large scale using very high-rate modern video codecs, and in an environment where there generally isn't a lot of professional support. And I think where the WebRTC deployment differs from previous deployments of RTP is the rate and the reach. There's been very large RTP deployments for telephony purposes, voice over IP, which have worked pretty well. But they've been done typically in very managed networks and have used very low-rate codecs. Right? You don't much care about congestion control if you're sending voice at 5 kilobits per second, or even at 30 or 40 kilobits per second. You perhaps do care if you're deploying video at 4 or 8 or 10 megabits per second to every web browser in the world. That potentially has much more impact on the network bandwidth, and it's much harder to control, because unlike an application like Skype, where you can just forbid it from the corporate deployment, corporate desktop cannot run Skype, it's pretty hard to say you cannot run a web browser. And once you've got the browsers, it's easy to download this JavaScript code and implement high-rate video anywhere. So we have a potentially very widely deployed high-rate video application with no really good appropriate congestion control. So I guess a bit of justification. Why do we not have good congestion control? Why can't we just use HTTP and TCP like everyone else does? Well, the issue is that TCP causes latency. The way TCP does congestion control is it continually probes and pushes the sending rate until it causes a packet loss, and uses that packet loss as a signal to back off. Of course, in doing that, it fills the queues in the network, fills the router, the queues in the routers until they overflow. And that queuing causes latency, potentially large amounts of latency. The sending rate of a TCP connection also doesn't necessarily match what we want for multimedia. Look at the graph that shows the typical sort of sawtooth pattern of TCP congestion window evolution. And that pattern doesn't come close to the pattern a video codec will generate. So you need some buffering to smooth things out to match the output rate of one to the output rate of the other. And finally, TCP, whenever it fills the network, whenever it causes a packet loss, we'll do a retransmission. And it will block the delivery of media until that retransmission has succeeded. So there's some head-of-line blocking for a round-trip time while a packet is retransmitted. Again, that causes further latency. Now, if you're building a video streaming application, that's all right. If you're watching Netflix or the BBC iPlayer or any of these other applications, a second or two's worth of latency before the video starts playing is absolutely fine. If you're doing a video conferencing application, a second or so of latency for your audio, your video to get to the person you're talking to makes it completely unusable. So the issue is latency. Right? We need an alternative to TCP congestion control that keeps the latency down. Both for itself, for the actual multimedia flows for the interactive video conference.
Yeah. Latency itself is not bad, but it shouldn't vary.
Latency itself is bad as well. For an interactive conversation, it needs to be below a couple of hundred milliseconds.
But when it varies, it's even worse.
When it varies, it's worse, but there's also a latency band itself. Yeah. So we need to keep the latency down for the video flows, and also both when they're fighting themselves, if you have two video flows flowing over the same link, and also when competing against TCP traffic, if that's possible. And the key point here is to build a protocol that keeps the latency down. These applications use a reasonable amount of bandwidth, but they're not greedy. They won't keep using more. Right? There's an upper bound on these applications, unlike TCP traffic. Yeah, they may need 2, 4 megabits per second, but that's all they need. They'll never consume gigabits. So, what's the IETF doing here? Well, 3 directions: circuit breakers, congestion control, active queue management. Circuit breakers, first of all. How do we stop these errant multimedia flows? Basic idea here is to build on the existing reception quality feedback that's in RTP and build something which looks at the media quality, looks at how it compares to the rate a TCP connection would get. So for those who know RTP, there are reception feedback coming back on the order of every 5-6 seconds or so in a typical RTP connection. That feedback contains basic performance statistics, round-trip time, jitter, packet loss, and the like. So we look at those statistics. We see, is the media quality going to be usable? Right? And that's obviously application dependent, but if you're seeing 2 seconds latency and 100% or even 50, 60% packet loss, clearly you're not going to be getting usable video over it. We look at whether the feedback's getting there at all, and we look at how it relates to a TCP flow. And I'm not going to talk through the equation, but this is a way of estimating the throughput of a TCP connection given packet loss rates, round-trip times, and so on. And we can estimate those parameters from the RTP feedback and see if we're going more than 10 times faster than TCP would over the same path, and use that as a signal that maybe we should slow down or stop if need be. And this works on a sort of timetable of 10, 15, 20 seconds, but it should hopefully stop flows that are causing serious problems. It's designed as a sort of last resort, working in parallel with congestion control. In terms of congestion control, the problem is how to adapt the media quality. If we wish to avoid getting high latencies, we clearly need something which doesn't try and fill the queues, unlike TCP. So we need something that's based on latency and delay as a congestion signal, whether that is increased relative one-way delay, whether it's increases in inter-packet spacing over the network. But we can use these as a signal that queues are starting to fill up and that we should back off before we fill the queues and before we cause packet loss. Fairly old idea, originally come from something called TCP Vegas 20 odd years ago. The ideas have evolved a fair amount since then. The IETF is currently working for a couple of proposals, one from Google that uses a filtered inter-arrival time as a congestion signal and is deployed in the latest versions of the Chrome browser. One from Cisco that uses one-way delay as a congestion signal and can work with explicit congestion notification to further reduce the delay if that's available. Both of these are being discussed in the IETF. Both of them, as currently specified, have some issues. The Google proposal has certainly been shown to oscillate in some circumstances. The Cisco proposal, as it's currently written, requires globally synchronized clocks, which is obviously a deployment constraint. I don't think either of these are fundamental concerns. Right? They all seem to be things where the usual engineering process can develop either of these into a perfectly reasonable protocol. And I would fully expect that to happen, although the timescale is probably another 18 months, 2 years, the rate at which the working group is happening. Finally, we're trying to fight against TCP, so part of the problem is how we avoid standing queues in the routers. This has led to a lot of interest in the IETF in active queue management techniques, so we can try and separate the media traffic out from the TCP flows. Now, the reason for this is that the delay-based algorithms are going to lose to TCP because the whole point of TCP is it tries to fill the queues and pushes anything that uses delay out of the way very aggressively. So there's a lot of interest happening in active queue management. There's a protocol called CODL that's getting a lot of interest in the open source, the Linux community. There's something called Pi from Cisco, which is going into some of the cable modem deployments. These will give obvious latency benefits if you can separate the TCP traffic and the media traffic, although clearly there are deployment issues with actually getting these out there, and it would be something that would be worth experimenting with on some of these testbed networks. So to wrap up, WebRTC is starting to happen. It's in the latest versions of Chrome and Firefox. You can play with it today. There seems to be a fair amount of developer interest. There's a fair amount of buzz around it. I think it's going to be widely deployed. The implications of this, I think for network operators, you are going to see a lot more peer-to-peer UDP traffic. Much of that being video, some of it also peer-to-peer data, and who knows what people will do with an easy-to-set-up peer-to-peer UDP data channel. The traffic will be protected via a circuit breaker initially, but not initially particularly well congestion controlled. The congestion control story will evolve over the next couple of years. It's going to take a while to get this right. In terms of implications for research, we clearly have some issues with how to make multimedia congestion control work well. We need to understand the characteristics of the networks and how they interact with the congestion control. We need to make sure the circuit breakers work as designed. And we need to understand whether these AQM solutions solve the problems they're designed to solve. Certainly, impact from network operators, impact from input from researchers to the IETF process where this sort of transport work is happening would be very valuable to make sure this works as specified. Okay, thank you.
Thank you, Colin.
I think we have room for one question. Okay, I usually don't do this, that I then ask a question, but now I actually do have a question, so I'll do it anyway. You said, okay, we can use the input from the research community. I assume with that you also address this community. But they're also very much an operational community. They run networks for the universities and research institutions. They run services for their constituency, including conferencing services. Should they start deploying WebRTC? Should they wait for those 2 years that you mentioned?
I would guess WebRTC will be deployed whether they like it or not. It's going into web browsers, and hardware that that has high quality video cameras in it is everywhere. So whether you want to deploy this or not, I think you're going to see it deployed in the next year, 18 months or so. Understanding how well it works and understanding where are the problems caused by that deployment, and understanding whether some of the AQM solutions being proposed, whether things like ECN can help, is certainly something where the network operators and the NRENs and the research community can give very valuable input to the standards process.
Okay. Thank you once more, Colin. I could add to that at least one large router vendor that also does web conferencing is going to do this. I will not name them. For the next half hour, we're actually going to do something a little bit different. We have a two-person or even three-person with a surprise performance show. And that also means that I'm not going to field questions immediately after this presentation, but really at the end of all 2 or 3 speakers. The first one, well, for those that are not familiar with the IETF, one of the things that happens there is that everyone that has sort of an official capacity in the IETF working group chair, IAB member, area director, they all have dots and to indicate their role so that people can come up to them and ask them questions. And we are very lucky to have here a person with a very special dot. For the women here in the room, it has the color teal. For the men, it's light blue. And that dot indicates RFC series editor. And Heather Flanagan is going to talk about her I would say, heroic adventures in fighting the ASCII art windmills. So Heather, the floor is yours.
Thank you. Yes, it has been a very character-building 2.5 years, which is how long I've been series editor. Now, since I don't have a lot of time, I want to make clear one assumption and 2 caveats before my start. The assumption is that everyone in the room has actually seen and maybe even read an RFC. Good, good. Okay, so now for the caveats. I'm not speaking for the IETF. I'm speaking for the RFC series editor. Second caveat. What I'm about to describe is in progress. It's not done yet, but it's where I'm going. So hopefully you'll find it interesting. When I started 2.5 years ago, I walked into my first IETF meeting and said, so what's your favorite problem with RFCs? And people said, please stop with the ASCII. Stop. I want characters that actually represent my name, that actually can use line art, that I can do more things. I want links. I want to stop losing information. I want metadata in my document. And I said, right then, how long have you been complaining about this? Oh, 15 years at least. I said, okay then. So I started collecting requirements and pushing through something that could look like rough consensus if you closed your eyes. But at the end of the day, in May, we went ahead and stated what we were going to do and what changes were actually going to happen. To summarize, The canonical version of RFCs, which is today plain ASCII text, is actually going to be the XML. It's going to be an XML file. And different versions of that will be rendered. You'll have an HTML version, you'll have a PDF version, you'll have the text version because there's some people that really, really like it. And you'll have an EPUB version. Non-ASCII characters will be allowed. They will be allowed in a controlled fashion. But people who actually want to spell their names as their parents spelled it for them are going to be able to do that. There's several other things going on besides format, believe it or not. The style guide, which had also been in progress for a very long time, since I think 2004, has finally been revised and approved for publication, so that will go out shortly. If any of you are involved in academia, you might be familiar with DOIs, Digital Object Identifiers. If you are in academia, you'll be very happy to know that we're going to be assigning DOIs to all past, present, and future RFCs. That often makes people's lives a little bit easier because in many cases, universities don't recognize a publication if it doesn't have a DOI. So we're fixing that. And the RFC Editor website, how many of you have gone to that? I'm sorry. It looks terrible. So we're working on making that actually look like it's not been designed in the early 90s at best. With that, there's several documents that are describing, back to format, what's going on there, describing the XML vocabulary that we're using. Of course, in order to describe that, we also needed to describe the one that was currently in existence, because that actually hadn't been written down yet. So we've got the V2 vocabulary, we've got the V3 vocabulary, we've got what the non-ASCII stuff will look like. Ironically enough, I'm hitting a problem where I'm trying to redefine RFCs using tools that limit you to how RFCs are currently defined. So when you go and look up, for example, draft Flanagan not ASCII, please don't look at the text version. It won't make any sense at all. Look at the PDF version. Also working with HTML, which is in a way a similar problem. SVG profiles have been defined. That's actually a functionally complete document. We're now working on some validators on that. And the PDF document is still in progress, so I don't have a 0.0 up. Was that fast enough, Klaus?
You're getting there.
And there we go. I can actually talk about this subject for days on end. So if anyone has any questions after, come find me. After. Leif.
Also,
and I know what you're going
Leif.
to ask. He doesn't get to ask questions,
So
but anyone else can.
Even though I'm not going to allow questions now, I do allow for an applause for him. So there will be questions afterwards, so no worries. And there is a break afterwards. You can ask all the questions you want. So the next speaker I don't have to introduce anymore because you have listened to him for a long time already in the morning plenary. But he had still a bit more to say. So Stephen?
Yep. So actually somebody told me that after I was talking too fast this morning, and I guess you're in a hurry, so I'm going to do it more. If you've been to IETF,
Stephen, if I can interrupt you for 1 second. I noticed that in your slides you mentioned opportunistic encryption, and also in the morning plenary you did. Can you explain a little bit what that is when you get to it?
Sure. So basically, I'm on the ISG. There's a note, well, you can read that later. So just talking about the IETF's kind of work over the last year, in Berlin last July, we had a kind of a side meeting on the evening of the plenary. There's about 30 people at that. A lot of these things get timed really well. But the X-key score slides came out just that day. So Jake Applebaum was at that. He was walking us through those. Then at the tech plenary there was something else, and then this week it's the tapping the Bahamas and so on. So in Vancouver in November we had a kind of a major kind of tech plenary where we got this. I think we established that consensus that we then wrote down in an RFC. We had a workshop jointly with W3C before the last IETF in London, which I'll talk about briefly. And then there's a bunch of people kind of doing stuff generally on this I mean, I think generally what you can say is that all of this pervasive monitoring stuff has kind of re-energized a whole bunch of people to do better at security and privacy stuff, even in ways that you wouldn't have expected. So out of the Sprint workshop, there's a workshop report, and this is one way that the IETF kind of does stuff, is to have an IIB workshop where we had 2 days. There was 100 people there. There was 150 wanted to come, so we had to say no to people, which made me quite popular. And the kind of output is this: it'll eventually turn into an RFC, and then normally that'll kind of influence other work, but not in a kind of prescriptive way. So you know, one of the things is crypto seems to work when it's well implemented. That's always a challenge. Probably we're looking at, in conjunction with CF4G, which is the IETF's kind of research group on crypto, we're looking at algorithm suites that we might want, because there is demand now for algorithms that are not necessarily part of the NIST suites. Not necessarily saying anything bad about NIST, but Cha-Cha 20, Poly 1305, and the 25519 elliptic curves all have reasonably good properties. Some of the cryptographic community seem happy with them. You're liable to see those as part of IETF standards, and they're already part of some browser deployments, for example, for TLS. But one of the points of that is that with the, let's say with the 25519 curves, it's ostensibly much easier to get a constant time implementation, which is then going to be much more robust in the face of side channel attacks of various kinds. We figured we need to learn a bit more about traffic analysis. It's aside from the crypto, we have lots of people who can talk about that endlessly and so on. But traffic analysis is not something that in the IETF community we have lots of expertise about. I think if you know people who are interested in that and they're interested in helping the IETF or the internet generally, that would be a fine thing. We have work going on to describe the threat model. There's an internet draft about that for the pervasive monitoring threat model. There's an RFC or a BCP, which is also a BCP 3552, which is guidelines on how to write security considerations for IETF documents. Later on, maybe towards the end of this year or so, when we understand a bit more about it, we'll try and update that with some guidelines for people developing protocols to say how to think about this new threat. We'll be talking about opportunistic stuff. I think there's a slide in here about that. I can't remember, but user interface, the IETF is pretty crap at, but probably that's a sad thing. And there was things like bettercrypto.org, which are not IETF activities. That's a group of people who are trying to document things like config snippets for Apache and Nginx, for how to turn on the set of crypto algorithms that we'd like people to be using today. So it's kind of a complementary exercise, and we should keep in touch with those. And there was a bunch of people who volunteered to, all ex-security area directors, which is the kind of role I have at the moment, who volunteered to write a document that says all IETF protocols should turn on security out of the box, which they haven't written yet. It'll be interesting when they do, because you can imagine serious pushback on that from lots of people. Opportunistic security, if you look at the web, I don't really have good figures, but the figures that you can find from some of the kind of SSL analysis sites out there seem to indicate that about 30% of websites do some form of TLS. And that's after 20 years. So that's pretty crap, because it's not hard. It's supported in all the browsers. It's supported in all the most important web servers, and it's still only 30%. Partly that's the fault of the security community and the web PKI, the way it's grown up, but there's things we can do about it. One of the things that we might do about it is investigate the use of opportunistic security. So the idea here is, in the past, I think you can criticize the security community for too tightly binding endpoint authentication with key exchange. So if you're doing TLS today in a web server context, you have to pretty much go to some CA, fill in some forms, or maybe even give them some money, and then eventually you get your stuff to work. Whereas you could easily turn on encryption, at least, without authenticating the web server. And there is some value to that. And particularly when we're considering the pervasive monitoring thing, if you think about that tempora type attack, which is purely passive on fibers, there is possibly significant value in that. So the idea essentially is to decouple endpoint authentication from key exchange, and then the subsequent use of the encryption functions. And interestingly, if you think about SMTP between MTAs, there's using Start TLS, which is a different environment from the web because of things like MX records and so on. But opportunistic uses of TLS already is a kind of a native feature of that particular protocol. And Facebook last week issued an interesting set of stats, basically saying that they've seen it go up to 58% of their outbound mail, of all the billions of notifications they send to people saying, your cat fell off a table or whatever. I don't know what notifications Facebook's saying, but whatever it is they do, they send lots of mail. And 58% of that is now encrypted. About half of that is encrypted opportunistically. About half is validating the MTA TLS endpoint, so checking the cert and all that stuff, which is kind of interesting. It seems to indicate that this is evidence that you could possibly double the amount of HTTP traffic that is going to use encryption if you had an opportunistic mode of doing it. The HTTP BIS working group we'll talk about in a second. There was some terminology, crapology about this. Opportunistic encryption is kind of not right as a term because the encryption is the same. It's the key exchange that's different. So somebody suggested opportunistic keying, which somebody else didn't like. So I think we're going to land on calling this kind of opportunistic security. We have a draft in the works which kind of describes this as a valid thing that you can do in protocol design or in application design, I guess, as well. And hopefully that'll be finished fairly soon. There is a bogus argument that gets raised against this, which is that you get a false sense of security. And the reason that argument is bogus is because protocols don't give any sense of security. Right? It's only when you get an implementation with a user interface that could possibly be relevant. So if you have that criticism, talk to your people who are implementing and not the IETF. There's a bunch of other things. So we formed this working group, UTA, for using TLS in applications, which Leif is also chairing, I guess. In December, there's a lot of old kind of specifications that say how to use TLS. Some of them don't use what we would currently prefer as the best cipher suites to use. The idea is to update that and do a few other things. We published BCP 188 last week. There was some buffs. We're trying to form a team of people to do privacy reviews of old RFCs. So it'd be good to do that because we have kind of now, because we have BCP 188, as part of the IETF process will be consider pervasive monitoring as you do stuff. But there's 7,000 RFCs worth of stuff already done that's not currently being worked out in that process. So it would be nice to get people to go back and look at that. And also the IAB, the Internet Architecture Board, which is kind of like the wise old people and the Foreign Office as well for the IETF. They have a security program, they have a privacy program, they're merging those. And if you're interested, I guess Ted Hardy seems to be leading that up. Or you can ask me and I'll point you in the right direction. So this BCP says that pervasive monitoring is an attack. It's the kind of process thing. There was a few mails about this back around Christmas. I think it was about 1,000. The UTA working group I mentioned already. We're updating stuff. It's also going to maybe document some attacks, consider how TLS is used in other applications, XMPP and mail and so on. TLS version 1.3 is being developed. They had an interim face-to-face. And they're trying to improve the performance and cryptographic properties. So for example, encrypting more of the handshake to give less signaling information that you can just get by passively looking at the TLS handshake. But it's not easy. I mean, there's trade-offs here. For example, the server name indication TLS client hello extension is used in order to do routing, essentially, of TLS sessions through TLS accelerators and also through virtual hosts and things like Apache. And that's basically normally a DNS name of the server you want to talk to. And it goes in clear in the TLS handshake. And it would be nice not to do that, but on the other hand, if you do not do that, you have that routing issue to try to tackle. So we'll see how that pans out. HTTP2 is another working group that's kind of interesting. They're developing HTTP version 2 based on Speedy. They've had a really significant debate about how to deal with all this stuff. I think it was very well done. And it hasn't all landed on a complete kind of consensus yet, but I think the debate was really well done. Mark Nottingham, who chairs it, I think did a really fine job. Currently it looks like they will define a way using HTTP version 2 so that your HTTP URIs, not the HTTPS ones, can be sent over TLS, thus providing that kind of opportunistic encryption or opportunistic security for the web, which would be a really good thing, I think. Not all of the implementers are keen on it. The bogus argument I mentioned earlier comes up earlier. But there are some also technical issues as to, is this going to be a mandatory thing to implement? Some of the browser vendors seem to be keen to do it, others less so. And another bogus argument comes up and says we should just do HTTPS everywhere, which of course I think is, well, I don't know how you can think it's a sensible argument, because you'd have to change all your web content that has any HTTP links in it. But if this group do define, even if it's not mandatory to implement, if they do define how to do HTTP over TLS without HTTPS, then I think there's a possible big win, like we saw with the Facebook stats. You could possibly double the amount of encryption, which would be really good. We're also looking at TCP, and there's a bunch of people who did TCP crypt. which is a fine proposal they brought onto the IETF a couple of years ago. I, amongst others, told them to go away, which was stupid. But at the time I was thinking, we have TLS, that's grand. Now my thinking is more that defense in depth and diversity is more worthwhile. So I think we're trying to suck them back in now, and they'll probably apologise. There is an alternative proposal based on TCP/AO that's being developed. That's likely to be a working group before Toronto. They have a charter. Martin Stimmerling is going to push it ahead into the IETF review. Check the list if you're interested. So that's basically doing TLS-like stuff without mandatory endpoint authentication, but allowing to hook into that in TCP. Dns Privacy is another one, which this would have been totally laughed at a couple of years ago. DNSSEC, for example, provides origin authentication and data integrity, but has nothing to do with confidentiality. There's some good work being done on problem statements, and the problem essentially is that the DNS names can expose information. So if you go and look up, stupidpoliticalparty.com, the DNS query kind of gives away what you're doing, right? And that DNS query is being monitored, same as everything else in things like Tempora. So there's a couple of good problem statement definitions. Saying how to solve the problem is a little bit trickier. It may require different solutions between the stub and recursive to authoritative. There are different scenarios. And then there's the issue of queue lane minimization. There's a mailing list, join it and so on. This RFC review team, it's not really a team so far, but I hope it becomes one. If you're interested, if there is some old RFC that annoys you, then go read it, and this gives you a way to bitch about it. That might have cause something to happen. So there's a couple of links there. If you're interested, send me a mail. We're using the IETF privacy mailing list for this kind of work. I'd really be happy if some people said they would do it. And Leif has promised me one, and Lucy's just did. Great. So doing that's a good thing. Certificate transparency is another working group that formed kind of recently. So CT is a Google proposal that is an experimental RFC now for how to do a write-only or append-only log, cryptographically audited log of the certificates that are produced. Some of the web PKI CAs are on board for using this. So basically this should help us to do things like detect DigiNotar-like events where certificates are misissued for whatever reason, either at runtime in TLS or by an auditor, essentially the owner of the relevant domain. So I think it seems like a good thing. I think there's enough traction behind this now, and it's essentially there was about a couple of years ago there was a bunch of proposals for like how do I have a large database of public keys? Could I use that to avoid DigiNotar-like incidents? And this seems to be the proposal in that space that's lasted. They're also going to look at other things like the similar kind of logging functionality for DNSSEC or other applications. So if you have a use for a cryptographically append-only log that uses Merkle trees to do that, then there's a place you could go and talk about that. It's not all related to pervasive monitoring. There is other stuff going on as well, apparently. ACE is a BOF last time at the IETF, which is looking like turning into a working group. The charter is there. The idea here is to do authorization or provide authorization support for these Internet of Things, which is a term I hate, small devices that need to do stuff. So for example, if in this space, there's a bunch of people who are working on CoAP, which is a RESTful protocol, HTTP-like, but more for constrained devices that uses DTLS. So they have some level of possible origin authentication, possible key exchange, possible confidentiality and data integrity, but no authorization story. So this group will be looking at how much of OAuth might be suitable, how much of Kerberos might be suitable, or with extensions or whatever. This is what they're going to be looking at. It's authorization for those devices. It may also have a JSON, Jose, square brackets kind of fashion angle too. That's. They're even looking at AdFab. Even looking at AdFab. God bless them. Okay, so that's it. The conclusion is you're updated. You will be updated again in the future, but by Tim very, very shortly. And thank you. And then you can read the note well again. Thanks.
Thanks, Stephen. Shall I just hand you the mic for a moment, or?
Hi, so I'm Tim Chown, currently in the IETF. I'm the chair of the new DNS or extensions for DNS-based service discovery working group. I just asked class if I could just have a couple of minutes just to explain what that is and why it might be relevant to you. So at the moment, for the sort of campuses and sites that the NRENs are connecting, if you're walking in with a device and you're hoping your device is doing service discovery of devices around you, typically the protocols like Apple's Bonjour, for example, MDNS, DNSSD, those are generally just working within the local subnet that you're in, within that local LAN. However, it's growing more and more common that the different devices around you physically will be in different subnets, and therefore you're not going to inherently discover them. So what we're looking at in the IETF in this working group is to figure out the best way of taking that discovery, or zero-conf discovery, and trying to extend it so that it can work over a campus type environment. That then might not be completely zero-conf. There may be some administrative intervention there to allow that to happen in a scalable way. However, what we'd like to do is to figure out the best way of doing that. So there's kind of 3 steps that we're working on there. The first is to gather requirements from sites like campuses. We're also applying the same thing to home networks, mesh networks, and other scenarios, but campus networks are one of the big use cases of this. And then to take those requirements forward, secondly, to define a new protocol for doing that service discovery. And then thirdly, the third thread of the work in the working group is to identify where there are issues with naming between the sort of MDNS, DNSSD type of world and the more traditional classic DNS world. And there's some sort of tripwires there. For example, the character sets that you can use in those names, for example, is just quite a fundamental thing there. So there's those 3 things. And what I'd be interested in, as one of the chairs with Ralph Johns, is if you can go and have a look at that working group, look at the requirements draft, and give us any input from the sort of campus views that you may have in terms of the requirements. Make sure that we're getting all those right, because we're trying to close off the requirements draft quite shortly, so we'd like to get it as accurate and fully reflecting the requirements as possible. And if you want to find that, just Google for DNSSD, all one word, -charter to see the charter of what we're doing, and DNSSD space requirements, and you'll find the requirements draft. So those 2 documents will be all you need to look at. Okay, thank you. If you've got any questions about that, feel free to catch me afterwards or whenever you see me. Thanks.
Thank you, Tim, and let's give him an applause as well. We do have a few minutes for questions to Heather, Stephen, or Tim. I actually want to start off with asking a question myself. When we saw these percentages of websites that were using TLS, the TERENA community has this, thanks to this Norwegian guy over there, Jan Meijer, has this wonderful thing called the TERENA certificate service that makes it for free or really cheap to get service certificates. And I wonder if anyone has any figures what that percentage would be in their constituency. Is it much higher? Anyone, any idea?
Do they know how many web servers they have?
Probably not, but I would guess that if you run a service that you're interested in seeing what's happening there, if typically universities start to use service certificates all across the board or not, or self-signed certificates or whatever. Okay, guess then I'll ask that same question next year again, and I hope that you can look into that. Any other questions? I'll bring the mic.
Hi, this is more a question to Stephen. You have talked about all these security initiatives. What I missed a little bit is routing. I know there's CIDR in the IETF, but there's still the issue of route leaks, which is, I believe, there's no really countermeasure today that I, as a CIA or whoever, leak routes from a small AS. I just initiated under the name of whatever. I mean, is there any activity emerging? Do you see anything?
There's been some mention. I guess in routing, people like in DNS have generally thought that it's kind of public information, so there's no real issue related to pervasive monitoring. there have been a couple of people who've said, yeah, we should think about this. Route leaks, I know, is kind of pretty controversial. It's independently controversial, nothing to do with pervasive monitoring. So I think if somebody was interested in doing work on that, then I'd be interested in talking to them, but I don't know of anything significant going on right now.
It's a big tool for pervasive monitoring, isn't it?
I don't think that we've seen any reports of BGP being used as a vector here, but sure, it could in theory.
What I want to say is that route leaks happens frequently in the internet backbone, but you don't know if it is a misconfiguration or used for pervasive monitoring. That's the point.
Right.
Yeah.
Yeah. But if people were interested in looking at the space of routing and pervasive monitoring, then sure, I'd be interested in helping to let them have that discussion.
Okay. I don't see. Oh, there. Oh, damn.
Selective vision.
I don't see anyone.
This is for Stephen as well. My name's Chris. I worked as a contributor on SCIM. And about your point about having pervasive security within all the protocols and all the RFCs, I think it's really great. But when you're in the actual process, we struggled with why are we focusing on the security and the endpoints? Should this not be another part of it? We need to take stock in what is going on in the protocol, but we felt that it was kind of a rat hole to go down inside it when we're really talking about provisioning, not about security, the best thing that can happen. So am I interpreting your perspective saying security should be happening in all the RFCs and all the things? They're right?
So, I haven't been keeping up to date with SCIM.
That's okay.
But if you're sending passwords in clear text across the network, that's a really bad idea.
So is it not sufficient to be delegating the endpoint security to TLS?
Is TLS mandatory to use for SCIM?
Yes. So it's these kind of conversations.
Here's the problem with layering, right? Layering makes it really easy to design stuff, but it also makes it really easy to turn stuff off, right? So we design these protocols to be layerable, right? The only way you can reasonably have a mandatory to use thing in habit obeyed is to build a security layer into the protocol in such a way that it can't be pulled out, right? Which a lot of engineers don't want to deal with, right? They want layering. We all want orthogonal solutions that layer neatly stack neatly on top of each other. So we tend to say, let's just use TLS, not only because we don't care about security, because we think that it's a good architectural design to sort of abstract that thing away. But it also makes it easier to turn off.
Well, if I'm being told that TLS is mandatory to use for SCIM always, then that makes me happy.
No, I know I'm going to allow one more question up there, and then I'm going to end it.
More to come.
I have a short question to Heather, and that is, can you describe how is life on the top floor of the Tower of Babel? Do you enjoy the view?
No. So one of the things that I have learned good and hard is that internationalization is very, very difficult. Even when trying to do something as, one would hope, as simple as saying, I want someone's name in the header to be in kanji, or, no offense, worse yet, Arabic, because now suddenly you're looking at bidirectional text and how that's going to work and how are you going to handle the indexing for that. I have tried to design ways to deal with that. So for example, when someone gives their name in kanji, they have to give not an ASCII equivalent, that's not right, an ASCII identifier, right? So that that's something that people could index. At the end of the day, the language of the RFC series is English. So we try to balance.
Okay, before letting you go, I do want to say that, and I think I can speak for Thomas as well, if I say, please let us know what you want to hear about next time. We are happy to organize another one of these sessions. So if there are burning questions you want to hear more about, come to either of us, and we'll try to get some great speakers. With that, I want to thank you for coming and participating in the session, and I would like to get one more applause for the speakers.